All right, welcome to the second video of Module 8, where we're going to start to do an example of a push-down automata. So just review the 7-tuple that is an NPDA. You have your set of states, you have your alphabet, you have a stack alphabet. So that's new. The stack alphabet was not on DFAs and NFAs, and also your initial stack symbol. Your stack must start with a symbol on it, and it cannot, your stack can never become empty. So the transition function, this is an NPDA, means non-deterministic. We do include lambda transitions. We also include the stack in our transitions. And after we make a transition, you can modify the stack. You can modify the stack by pushing onto the stack, by popping off the stack, by ignoring what's on the stack, or by replacing what's on the top of the stack. So let's get ready and do some examples. So the first example we're going to count the number of A's and then make sure we have the same number of B's. So we know that this is a context-free language. We've already been through that. So now let's build an NPDA for this language. And as I do that, I will go over the transitions and everything and slowly, and then we will try some strings and see if we end up in an accepting state. All right, so we start out with Q0, and then we start to do our transitions. So the first thing we need to do is we need to start counting our A's. So this is how the transitions work. First of all, our alphabet here is A and B, and our stack alphabet is going to be our starting stack symbol and A. So every time we get an A, every time we encounter an A, we're going to push an A onto the top of the stack, and then after we have pushed all of the A's on top of the stack, when we start to encounter B's, we're going to pop the A's off of the stack, and if we end up with the starting symbol, then we will know that it is a in this language, same number of A's. So basically we count the same number of A's by pushing A's onto the stack, pushing A's, which is our stack alphabet. Every time we get an A, we push an A onto the stack, and then every time we get a B, we pop an A off of the stack. So we have to, of course, if you start with A's and then you start getting B's and then all of a sudden you get an A, of course, obviously that's not going to be in the language, and also you can't begin with a B. That's not going to be in the language. A single A is not going to be in the language. So we are going to have to take all of these things into consideration. So let's look at how to read the transition function. So I have two transitions here, and let's read these transition functions. So the transition just means I'm in Q0 and I'm going to stay in Q0. So that's the same. That's making the transition. You can see I'm in Q0. I'm going to stay in Q0. This is what I'm going to consume. I'm going to consume an A in the string. So if the first letter of this string is an A, and I know it's the first letter because this right here means the top of the stack. So if the top of the stack is the initial stack symbol, which is a Z, if there's a Z, then I know I'm encountering my first symbol and it's an A, so I'm going to push an A on here to count my A's. If I encounter another A, I'm just going to push another A on here. And as long as I encounter an A, I'm going to continue to push A's onto the stack until I encounter a B. So let's go over how we do this. We're counting our A's. The second, this is a transition, so this represents the stack, this represents the symbol and what's on the top of the stack. So if the current symbol is an A and the top of the stack has a Z, I'm going to push an A. I'm going to push a stack symbol A. So keep in mind there's two alphabets here. You have our stack alphabet, and then you have your actual alphabet, which are the symbols that are in the strings. All right. So that's counting my A's. I'm going to count my A's. Now I also added this other transition because this transition, if you look at this string, no A's and no B's is also in the language. So this is how you're going to get to the final or accepting state. So here, if there's a Z, I can take a lambda transition over to the final or accepting state, and I just leave the stack alone. So here you can see that I'm pushing an A, and you can see here that this is the top of the stack and I'm pushing an A. Here, this is the top of the stack. I'm leaving the stack alone. All right, so that's how you read that. So let's keep going. So now I'm counting my A's. I keep counting my A's. And now, after I start counting my A's, I get a B. If the next symbol in the string is a B and there happens to be an A on top, I'm going to pop that A off. So that's what this transition looks like. This is a pop. This is a push, and this is a leave the stack alone. So I start counting my A's. I keep counting my A's, and then if I finally get a B, then I'm going to move into another state so I can start to count my B's. So every time if there's an A on top of the stack, I'm just going to continue and continue as long as there's an A. I'm just going to continue to count my B's, right? So I want to count my B's, I count my A's, I count my B's, I want to make sure that they match. And then finally, I have a transition that says, all right, now I have counted all my B's and I'm done, and now I've reached the bottom and my A's and my B's match, so I'm going to take a lambda transition over here and the A's and the B's match, so that means it's in my language. All right, so we're going to run through this with a little stack and everything in just a minute, but before I do that, let's just add the other transitions that will go to the trap state. So if my first symbol is a B, this means my first symbol is a B because my stack is, a Z is my starting stack symbol. I'm going to leave the stack alone and I'm going to go to a trap because I cannot have strings that start with a B. And also, if I have my B's and as long as there's an A, I will pop off. But if I have more B's than A's, then this would be more A's than B's. So I've already popped off, and now I have another B in my string, and that other B in my string, I don't have another A to match it, so that this means more A's than B's, then I'm also going to go to the trap state. All right, so now let's go through this and let's pick some strings and see what happens. So we can pick a string A, B, B, B. I know that's in the language. We'll pick a string that's not in the language, A, B, B, and A, B, B, B. No, A, B, B. All right, so we know that this one should be in the language, so let's follow the transitions and see what happens. So we'll start with this first one. So here's our stack, my starting symbol. So my first symbol right here is A, right? So I read the A, I read the A, and there's a Z is there. So what am I going to do? I'm going to push an A onto the stack and stay in Q0. So now I've consumed that one, and now I get to my next symbol. It's an A. There's an A on the stack, so I'm going to push another A on there, and that symbol's done. Then I'm still here in Q0. There's an A. There's an A on the stack. I'm going to push another A on here and stay in Q0. Now I have encountered a B, right? So now I'm here. I've encountered a B. So what am I going to do? I'm going to look at the stack. I have a B, and there's an A on the top of the stack, so I'm going to pop that A. Oh, here's my stack. Pop that A off and consume the B and move to Q1. Now I have a B, there's an A on the top of the stack. I'm going to pop that off. And now there's another B, and there's an A at the top of the stack. So I'm going to pop that off. And now I've gone through my whole string. So now I can see that there's a Z here. So I'm going to take the lambda transition, and this is accepting. All right, let's try the next one. So I start out with an A. So the transition is I have an A and there's a Z on my stack. So I'm going to get rid of that A and put an A on my stack. Now I have a B. I see that I have a B and there is an A on the top of the stack. So I'm going to make this transition right here. I'm going to jump here and I'm going to consume that B, and that the A is going to pop off right there. All right, so now I have a B. I have a B and there's a Z. All right, so look at this. I have a B and there is a Z. So since I have a B and there's a Z, I'm going to go to the trap state. So I have more B's than A's. So this is not going to be accepting. Now let's see what happens if I have more A's than B's. I start with the A. There's a Z on my stack, so I'm going to push an A onto the stack. Then my next is an A. There's an A on the stack. I'm going to push another A onto the stack. And then I have another A, and there's an A on the stack. I'm going to push another A onto the stack. So now I have a B, and there's an A on the stack. So I have a B, and there's an A on the stack. I'm going to pop that off. All right, and now I have a B, and there's an A on the stack. I'm going to pop that off. And now I have nothing. So I'm in this state right here, and I don't have any more symbols in my string. I cannot make this lambda transition because there's still an A on my stack. So it will not take me to an accepting state. So again, this is an NPDA. You don't need to define every transition for every trap, but if you are stuck in a state like this that is not accepting, then your string is not going to be accepting. So hopefully you can take a look at this. This is also drawn in the notes with all of the transitions and everything. And in the next video, I'll do another example.